Hi students, welcome to my YouTube channel SADHIK Physics. Learn the physics very easily through my channel. No? So today we'll discuss one important topic, that is alternating current. Okay, so compulsory one question from NEET and IIT-JEE, right? Even advanced level also compulsory the question will be there, right? So let us study detailedly. Very easily you can learn this and easily you can score the marks through this chapter. No, so let us see. So listen this class, listen this video, right, so that you can do any type of questions which is related to the alternating current, right? We'll discuss thoroughly about this alternating current now. Let us come. So first of all, before going to discuss alternating current, let us discuss what is a generator now, right? So let us see here alternating current. Before alternating current, let us see, we'll go for dynamo, or we can call it as like a generator now, right? So generator, right? You might have seen we are using electrical energy, right, in our houses, current and all electrical devices like bulb or fridge or AC or TV, all this one, so we are utilizing the only alternating current now, right? So from where this alternating current is developed, therefore from the dynamo, that is nothing but a AC generator. You might have seen the generators, simple small generators in our your houses onto this, right? So first of all, let us see what is this generator, how this generator is right, generating the electrical energy. Let us see now, right? So what is this generator now? Generator or dynamo. So with this dynamo, what it will do, it will convert mechanical energy to electrical energy, right? Electrical energy. How it is going to generate it now? Let us see now. So here it is going to use Faraday's law. So how the construction of the generator is there, So this generator it is consist of like a like magnet, so which is having north pole and south pole, right? Very strong magnetic field will be generated, or very magnetic field it will be applied across this point. So here what we are going to do, we are going to take one armature, therefore here what is this armature? It will be having one coil, a copper wire. It is wound very large number of turns onto this one, which is wound on a one shaft rod. So this is kept on a one shaft rod onto this. So this is fixed. So this total wire windings, which is insulated copper wire, so this winding, so it will make like a one armature, or this is, you can call it as like a coil, which is having large number of turns. So which is having large number of this turns it will be there, and this is mounted on a one shaft rod. So this shaft rod we are going to rotate it now by any different means, by different any mechanical energy. What here we want to rotate this one now. How we are going to rotate it now? So we can use it like a thermal power station. What thermal power station will do? So there the coal is burnt. The coal, what will happen now? The coal burnt, that heat energy given to the water. Water will convert into like a steam. That steam is sent it to this one now. So when the high energy wind, steam is sending, so this it will be able to rotate it with certain speed. So this armature is also going to get rotated now. So that is called like a hydroelectric power plant. So similarly, hydroelectric power plant also. So here water will be there at topmost height. So the water will be flowing down, converted into potential energy, converted into kinetic energy. So it will be falling on the blades of this one. Therefore, due to that kinetic energy, therefore it will be able to rotate. Even wind also it is flowing, therefore it will make it to rotate. Ultimately, our thing is what we need to rotate this one. When you are rotating so what will happen now? It is going to generate the EMF. How it is going to generate now? Let us see. So therefore here we are going to use it as our Faraday's law. Therefore here there is a magnetic field is there. Here initially the coil is like this. Suppose there is no magnetic flux linked with this one, because it is like this, flux it is zero onto this. Now what we are going to do? We are going to rotate it onto this. When you are rotating like this, so what is going to happen now? The field lines are cutting to this one. Therefore the number of field lines are increasing onto this. So when the flux is increasing, therefore the EMF will be generated by using the Faraday's law. Now again what we are doing now, we are rotating like this now. Again the flux is becoming 0, therefore EMF also will become 0. Again we are rotating now. So therefore again the field lines are increasing, therefore flux is increasing. So due to this increase in flux now, therefore again EMF will be generated, but in the opposite direction on this. So in this way, therefore the flux, it will be changing across this one now. So this change in flux, therefore it can be collected by the, therefore one slip rings onto this. There will be one slip rings are there. So it will be collected. So with the carbon brushes onto this one now. So it will be collected onto this. Therefore these are connected to one external load. Therefore whatever we are utilizing our energy, so this energy is coming from these rings onto this by rotating onto this. So how to calculate the EMF which is generated in this one? We are going to use Faraday's law. What does Faraday's law tells now? EMF which is generated, induced EMF, is nothing but a rate of change in the magnetic flux. Clear? So what is the magnetic flux here now? You know the flux formula. Flux formula is nothing but NBA into cos theta. But here theta is what? Here omega is there no? Omega means angular velocity, omega by t. Omega is equals to theta by t. Therefore theta is equals to omega t. Substitute in this one. Therefore what you will get it now? The flux it will be, so here therefore NBA into cos of omega t. Clear? So NBA cos theta, cos of omega t. So you try to differentiate it now. So what is going to happen now when you differentiate it? So here E is equals to minus. So therefore NBA, so it is constant no, NBA. So we are changing what? We are changing only angle onto this. Therefore area vector we are changing onto this one now. Therefore we will study detailedly about this flux and all this one now in a EMI. So electromagnetic induction will detail onto this, right? So cos of omega t. So here differentiation of cos is nothing but a minus sign, minus of minus plus NBA into omega into sine of omega t. This is your EMF which is there. So this is what a number of turns is fixed. B, magnetic field is also fixed. Area of this coil is also fixed. Amount of rotation is also fixed no. So these all are the fixed values no. So which will, if all these values are maximum, that will give us like a peak value. E is equals to E naught into sine of omega t. So what is this E naught value? This is nothing but E naught, we can call it as like a peak value. So therefore how to calculate it now? NBA into omega, or NBA omega you can write down 2 pi into frequency. Clear? So how much faster you are rotating now? So EMF peak value is also will be more. If frequency is more, peak value is also more, right? So in this way the peak value, so therefore that can be calculated by using number of turns and all this one no. This is this frequency. In our India, so we are going to rotate with a frequency about 50 hertz. So in India, therefore all the generators no are rotated with a frequency of 50 hertz. Some other countries no, they will be using like a 60 hertz also, in USA like that. So in India we follow frequency is about 50 hertz now. Therefore 50 rotations per second onto this, right? So this is what? This is nothing but a EMF. How it is changing now? By changing its sine of omega t. What is the sine value? No, maximum value is +1, minimum value is -1. That means, so voltage is changing from high value to the low value. So therefore this is like a sinusoidal function onto this one now. Therefore here voltage is continuously changing. So this we can call it as like a alternating voltage. And the current through this one now we will call it as alternating current. Clear? So let us discuss detailedly so about this alternating current, and if this current is applied to across the bulb, across the resistor, across the capacitor, across the inductor, so what is going to happen now, and how the tuning circuits it will be designed onto this. So let us discuss onto this now very detailedly in the alternating currents. Now we will discuss alternating current. So let us go for basic terms, basic things no. So first of all alternating currents no, just now we calculated E is equals to E naught into sine of omega t. We know we calculated as E naught, therefore NBA into 2 pi into frequency. Clear? So we use frequency, right? Different frequency is 50 hertz. So here this is your alternating voltage. So what is the current now? Current is nothing but a EMF by R, right? So Ohm's law, therefore E naught by R into sine of omega t. So I is equals to I naught into sine of omega t. This is called I naught. I naught, how it is there now? E naught by R. This is called alternating current. How it is there now? Therefore, let us see here, this is nothing but a sinusoidal function. How it is there now? Here the current or EMF, so with respect to the time. So what will happen now? How this will be there? So you can see sine function now. Therefore, you can go for sine function like this. Sine 0, time t is equals 0. So therefore, sine 0 is nothing but a 0. So value is 0. So here like this, therefore throughout this time period, this is 0, t, therefore t by 2. So t by 4, so therefore 3t by 4. Clear? So this is your alternating current onto this, right? So alternating voltage, like one positive cycle is there, negative cycle is there, like that. Now this is like a sinusoidal function, sometimes like a digital one, it is also, it will be there. So digital way of alternating current or sawtooth waves, like that, different ways it will be there. For NEET and IIT-JEE, this is enough for you. So need not to go for different ways onto this, right? So here basic things now. Can you tell me what is the average value? What is the average current and average value for complete cycle, for a full cycle? So here how much amount of positive value is there, that much amount of negative value will be there. For one full cycle current, average current, it will be the 0. Average EMF, it is also equal to 0 for complete full cycle, for full cycle. You understand? Then average current is 0. Therefore, how to calculate it now? Therefore, effective value, how to calculate it now? Therefore, here there is a, these are the peak values, these are the peak values, right? Right. So this is your I naught or E naught, therefore this is I naught minus. Clear? So what is the average values now? Average values are 0. So therefore what we will do, we will use effective value, that is nothing but a, so RMS values now. What is this RMS value? So root mean square, right? Name itself is there. So IRMS or ERMS. IRMS, RMS means what? Root mean squares of this current. Clear? So like this means is average of the squares and we are applying the root, right? So this is your RMS value. How to calculate it now? What is the value here now? Therefore I naught by root 2. I naught is nothing but what? This is your peak value, right? ERMS is how much now? ERMS is nothing but a E naught by root 2. This is your RMS values. Clear? So therefore it is nearly equal to 70% of this peak values now. Therefore this is your you can draw the 70%. Therefore here this is your up to this one now, this is nothing but a RMS value. 70% of our peak value is nothing but a RMS value, that is nothing but a virtual current or effective values. So we will take it as these values only for our calculations. Clear? So now how to measure it? How to measure it? Therefore RM, right? So alternating currents, therefore AC ammeter. How it is going to work now? AC ammeter will work based on the heating effects of current. Heating effects. Why? Because direction does not depend on to this one. This is your resistance. Either current is going like this, doesn't matter on to this one. So AC ammeter, therefore it will work based on the heating effects. DC ammeter, it will work based on the deflection onto this force experienced by the current carrying conductor, like galvanometer we discussed. Clear? So AC ammeter, so it will work based on the heating effects. What is this AC ammeter will read? So it reads only RMS values. It will not give peak values. So it will read only the RMS values now, not the peak values now. Clear? So therefore this is your AC ammeters, no, therefore so it will work on to this, right. So now what is the power, no, power, what is the power, no, power is nothing but a ERMS into IRMS into cos phi. Cos phi is nothing but a power factor. Let us see, in this way we can calculate the power associated with the alternating voltage. So therefore you can read it as power, it will be equal to ERMS nothing but E naught by root 2, IRMS is nothing but I naught by root 2. So therefore root 2 into root 2 is nothing but 1 by 2 I naught into E naught into, sorry here no, cos of omega t, cos phi, you can rewrite it as cos phi. Clear? So therefore this is the power formula. So this is an average power which is induced, so due to these alternating currents. Now this is a power formulas, no, you can calculate it now. Clear? So what is this cos phi? Cos phi is very important point, no. So you should understand cos phi. Cos phi we will call it as like a power factor. What is this, now how to calculate very easily. So this is power factor is nothing but a cos phi. Clear? So what is this phase now? Phi is nothing but a, this phi is nothing but a phase difference. We already discussed in waves, no. So the phase difference, no. Therefore when there is a waves, so there will be in the form of a like a phase difference will be there. We will discuss what is that phase difference also. So if phase difference is 0, therefore if phase difference is 0, so cos phi value is maximum now. Power factor value is cos 0 is 1. Therefore it is maximum power dissipated, no, when phase difference is 0. When phase difference is 90 degree, so therefore cos phi value cos 90 is 0. That means power dissipated will be 0 if there is a phase difference is 90 degree. Clear? So this is your power factor. So that can be, power factor is cos phi. Complete we will call it as like a power factor onto this. Clear? So therefore this phi is nothing but a phase difference now. So how to calculate this phase difference now? Let us see now. Please, very easily. So you can calculate it now. These are the slightly some basics related to the alternating current, right? So now let us see what is this phase difference now. Now let us see here now, EMF is there, no. EMF is equals to E naught into sine of omega t. But current I naught into sine of omega t plus phi is there. Okay. So what is this phase difference now? What is this phase actually? Phase means this angle which is there, no, at what position. This omega t is nothing but a phase. Omega t plus phi is there, no. This is nothing but a one more phase here, no. This is phi 1 or phi 2. So you can write down phase difference, no. So therefore you can subtract it this one now. Therefore phi 2 minus phi 1, no. So you will get it as phase difference. You can subtract this one now. You can get it as like a phi. So just try to subtract it now. So phase difference between the current and voltage. Clear? Right? Now, okay, if you know the phase difference, you can calculate the time difference. What is the time difference formula? Time difference is nothing but a delta t by t. Delta t by t. So it will be equal to phase difference delta phi by, for one complete wave, therefore it is nothing but a 2 pi. So time difference you can rewrite it as, so t by, therefore 2 pi into phase difference here now. Clear? This is called a time lag or time difference. Time lag we can calculate by using this formula onto this. Clear? So these are the slightly basics, no. Therefore basic terms, right, related to the AC. These are the things, no, you should know it compulsory. Then only you can able to calculate further things onto this, right. So this is your alternating voltage, alternating current. So how the alternating sinusoidal wave will be there. So average value is 0. So we will calculate the effective value, that is nothing but RMS values. So can be calculated I naught by root 2, E naught by root 2. So this alternating current, alternating voltage is measured by using the heating effects of the current, right. So therefore it will gives us like only the RMS values, not the peak values now. Therefore Here it is given. Therefore, power ERMS into IRMS into cos phi. So, phi is nothing but a phase difference. You can calculate the phase difference. You can calculate the time difference onto this. Clear? So, whatever the, if suppose in any question, no, if like this is given, that means your equation format is given, no, then you have to take the peak values. If it is not given like a equation form, they will give some values like this. So, like you can tell this one, no. Suppose let us take this one, no. Therefore, this is one resistance is there. So, this is your alternating current, it is there, no. Therefore, here in our houses we will use always 220 volts and 50 hertz. In our houses in India we will use 220 volts and 50 hertz. This 220 volts is not the peak value, like this is given, no. This is nothing but a RMS voltage. This is nothing but a with what frequency it is rotated. Suppose sometimes if it is given like this, suppose any equation is given, E is equals to 300 into sine of, therefore 100 pi t, like that it is given, no. Suppose 100 pi t is given. So, therefore, this 300 is there, no. If this type of equation it is given, so this is nothing but a peak value, not RMS value. Or if they mention, only you have to take it now. If they do not mention, these values are nothing but a RMS voltage only, RMS values only. You understand, no? Therefore, you can take this one now. This is nothing but a omega. Omega you can write it as like a 100 pi. Therefore, so this it will be your omega. Therefore, it is nothing but a 2 pi f into, it will be equal to 100 pi. F is equals to 100 pi by 2 pi. Therefore, it is nothing but a 50 hertz. In this way, you can calculate the frequency. Frequency is okay, but this value is peak value, but this value is RMS value. Clear? Right? So, in this way, you can calculate. So, whatever the voltages, all this one, no? These are the basic terms which is required to do alternating currents now, right? If you are thorough in this one, no, then rest of the thing is simple mathematics onto this one, no. So, just mathematically you can able to solve all this. Clear? So, now let us apply alternating current. So, across the resistor and across the inductor and across the capacitor. How that effect it will be there, let us discuss detailedly now. Clear? Suppose if you are going to, right, so alternating current across the resistor. So, there is a one resistor is there, this is one resistor. So, here we are going to apply one alternating current, right. So, what is the alternating current here now? E is equals to, therefore, E naught into sine of omega t. Clear? So, this is your peak values it is given now. Now, what should be the current here now? Current. So, here the current it will be flows on to this one now. So, current we can write it as like a Ohm's law. Therefore, E by R, E naught by R into sine of omega t. So, therefore, here I naught you can write down E naught by R. This is nothing but a peak value of the current onto this. Therefore, I is equals to I naught into sine of omega t. This is the current. So, this is your voltage, right, alternating voltage. Clear? It is a very simple one now. How to calculate now? Peak value. So, in this way you can calculate. If they are asking RMS value, you know how to calculate it now, right. Let us do some numericals now after this. So, one by one now. So, now let us see this one now, right. So, what you observe this one now? This is also having the same phase, this also is having the same phase. Therefore, what will be the phase difference here now? Phase difference is nothing but omega t minus omega t, so that it is nothing but equal to 0. Clear? So, phase difference is 0. What will be the power factor now? What is the power factor? Power factor is nothing but cos phi, that is nothing but cos 0, that is nothing but equal to 1. Therefore, maximum power dissipation will take place. So, phase difference is 0. What will be a time difference now? Time difference is nothing but t by 2 pi into phase difference is 0. Therefore, that is nothing but a time difference. So, time difference it will be equal to 0. That means there is no lag, there is no lead, right. So, instantaneously how the voltage is changing, like that only the current is also changing onto this, right. So, there is no lag onto this. So, what will be the power dissipated here now? Power, it is nothing but a 1 by 2, therefore E naught into I naught. Clear? So cos phi is nothing but 1. So this much amount of power it will be generated now. Clear? Or this much amount of power it will be dissipated. Clear? So power it will be equal to 1 by 2 E naught into I naught. Clear? So now one very important point you should understand in alternating currents, that is nothing but a phasor vectors, right? So let us see very detailedly about this phase diagrams. So phasor diagram. What is this phasor diagram? This phasor diagram is nothing but a like a rotating vector or some vectors. So these two vectors are there, like a current vector and voltage vector, like that. So these vectors so are represented. So the angle between this current vector and voltage vector is nothing but a phase difference. Whenever you are dealing with a waves like this, therefore you have to take the phase. Therefore you can solve that concepts by using like a phase vectors. That is simply you can use it as like a parallelogram law of addition of vectors. So therefore we can write it as like a phasor vectors, phasor diagram. This is important one, phasor diagram. So phasor means what? Is nothing but a vectors, right? Phasor vectors. So how to draw it? Phasor vectors. Very simple one. So what is the voltage and current? It is what is the phase difference? Phase difference is 0. Means what? Both are lying in the same direction. Which is having more value? E naught will be having more value. Why? I naught is having less value. Why? Because I naught is nothing but E naught by R. Therefore here this is your E naught. So I mean E vector, that is a voltage one, and here you can rewrite it as like a this is your current. Why both are written in the same direction or same vectors here now? So why? Because the phase difference between them is 0. Clear? So this is nothing but a phasor diagram now. Therefore the current vector and voltage vector, right? So the angle between them two vectors is said to be like a phase difference. So that vector representation is nothing but a phasor diagram. So why this is important? Because we can solve the problems related to this alternating current very easily. Clear? As there is no time lag onto this one, so what you can write it now? Therefore here we can write down the waveform. How the waveform it is there now? So here it is E, right, and I with respect to the time. Let us write down here. This is here E, and let us write down here. So therefore here I. There is no lag in this one now. Therefore this is I. Why the peak value is less? No, because of due to this reason onto this. Clear? So this is your waveform and this is your phasor diagram. This is a power, time difference, power factor, phase difference. These are the currents onto this. Clear? So among this one, which is more important means I am telling phasor vector, phasor diagram. This diagram we are going to use it so many times. Clear? So this diagram you should be very perfect onto this. What is there? Simple onto this one. These are nothing but a phasor vectors. Clear? In this way we are. When here one more important point, if you apply the voltage, therefore alternating current across the resistor, power dissipation will take place across the resistance. Why? Because there is no depend on the polarity onto this. Clear? Now next one, suppose if you are going to apply so AC across the inductor, AC across the inductor. There is an inductor, we are going to take it now. So this is one inductor. So and this is your alternating voltage here. E is equals to E naught into sine of omega t. Clear? So therefore this is an inductor, it is L. So here what will happen now? Current it will be there. So due to this current therefore the magnetic field it will be generated now. So but here alternating current current magnetic field will be increased in positive cycle, negative cycle field will be decreased. Initially field was like this, finally field will be changing continuously the flux is changing now. So due to this change in flux there is an opposing EMF like a back EMF it will be generated. This we studied in electromagnetic induction now. So how to calculate this back EMF now? EMF is equals to minus L into di by dt. So this is your self induction formula. In this way the back EMF will be generated. Why? Because the continuously the magnetic flux is changing onto this one. Change in magnetic flux gives us like EMF now, that is nothing but a Faraday's law. So that can be calculated by using this formula. So then it is reacting now. See how at what frequency is changing now, that much amount of it is reaction is there now. That means so the inductance is there now. Therefore this it will be showing some reactance. Let us see what is that. So this EMF and the EMF is will be the same, minus L into di by dt. It will be equal to E naught into sine of omega t. Clear? So taken here now di, it will be equal to E naught by L. So therefore this is minus. So therefore sine of omega t into dt integral now, integral. So this it will give us like current. Therefore here E naught into sine of this one means integral sign means minus cos. Therefore so right, so minus cos, so minus E naught by, so integral sine of omega t by, okay, that is nothing but a cos of omega t divided by omega, right? So therefore it will be omega L into, so cos of omega t. This minus here no, current I is equals to E naught by, therefore omega L into cos of omega t I can write down. So same sign should be there no, sine of omega t minus pi by 2. Clear? So means it will lies in the first quadrant no, so it will become like a positive onto this, right? So this value we can call it as like a peak value, peak value. So therefore here I is equals to I naught into sine of omega t minus pi by 2. Clear? You understand no? What is I naught now? I naught is nothing but a E naught by, therefore so omega into L. So this E naught by R we have to write it now like that. So therefore E naught by XL. Why XL now? XL is nothing but a inductive reactance. Why? Because it depends upon the frequency, at what frequency you are changing no. So therefore it depends upon this frequency. So this XL we will call it as like a omega L, that is nothing but a 2 pi f into L. So this is called inductive reactance. Clear? So inductive reactance now. So you can rewrite it as here inductive reactance is there no, this inductive reactance. So it depends upon the frequency, directly proportional to the frequency. Here inductive reactance and frequency directly proportional. Therefore XL is directly proportional to the frequency. That means if the frequency is larger, so therefore XL will be also larger. That means the reactance will be larger. So therefore the potential difference across this one is larger now. Clear? So here reactance is larger means current will not flow onto this one no. So therefore this when it will become like a reactance is larger, like a resistance is larger, so it will act like a open circuit. Very very important. At higher frequency inductor will act like a open circuit. So at frequencies lower, that means decreases, inductive reactance it will be decreases means low resistance. Low resistance means what? It will be conduct the current will be more. So therefore this it will be act like a short circuit, right? When low frequency is there no, it will act like a short circuit. That means for DCs no, it will act like a so short circuit no. Short circuit means just simple one wire onto this, right? So here XL no, so for higher frequency onto this. Clear? Actually what is this AC and DC no? Therefore here DC is nothing but a battery, the current which is coming out from the batteries or cell onto this one no, that are nothing but DC currents no, right? So which are coming out from the generator no, that is nothing but a alternating current, right? So direct current will go for like a directly, there is no change in the direction onto this one no. So which is given by the batteries, that are nothing but a DCs. So which are given from the generator, that is nothing but a AC. Keep in mind this is one simple point. Okay. So inductive reactance no, therefore it is like this. Now tell me what is the phase difference no? Phase difference. So this is your omega t and this is your this no. So this is omega t voltage minus omega t minus pi by 2. So what you can write it now, omega to omega can cancel. So phase difference it will be equal to pi by 2. Clear? So phase difference is how much now? Pi by 2. Once phase difference is pi by 2, so therefore what you can write it now? What will be the power factor now? Power factor cos phi cos 90 cos pi by 2, that is nothing but a 0. So power factor is 0. What about the power no? Power is also is nothing but a 0. That means there is no power dissipated across the capacitor, inductor onto this. That means there is no loss of the power across that. You understand no? There is no loss. Clear? Only if resistance is there, then power loss it will be there. Now what will be the time difference here now? What will be your time difference now? So time difference it will be t is equals to t by, therefore 2 pi into phase difference is pi by 2, pi cancel, therefore t by 4, therefore 1/4 of this one now. So this it will be a time difference. Clear? So can you tell me which is leading and which is lagging? So which is leading and which is lagging now? So therefore here you can see the phase now. So the phase is nothing but omega t, here phase is nothing but omega t minus pi by 2, which is greater? Which is greater? Omega t is larger now. So omega t minus pi by 2, it is lesser onto this one now. That means here which is having larger now, therefore voltage is having larger phase now, therefore voltage leads the current, or current lags the voltage. You understand no? Therefore which is leading now? Voltage is leading. So which is lagging now? Current is lagging. Clear? So voltage leading and lagging now, you can rewrite it here. So there is no power dissipated. This is your time difference now. Now we can go for what is the phasor diagram. Very important phasor diagram no? Right? So phasor diagram, very important. What is the phasor diagram now? Therefore here voltage is leading, that means here this is your current now. So this is your VL. Clear? Or you can rewrite it as, therefore this is your voltage VL and this is your current. This will not use it, this only will use it. What will be your phase difference here now? Therefore phase difference is nothing but a pi by 2. You understand no? So this is your phase difference and this is your phasor diagram. Clear? Phasor diagram. Right? So therefore these are the right. So information, that is if you apply the alternating current across the inductor onto this. Clear? Now similarly we will apply the alternating current across the capacitor. In this one, what is the important means phasor diagram is important and this inductive reactance is important. Very important. Clear? So now what is your peak values now? E naught by XL. This is most important. Clear? Inductive reactance is most important. Clear? Now let us see. We will apply alternating current across the capacitor. So this is one capacitor is there. So capacitance is C. Now we are going to connect one alternating current, alternating voltage. Therefore, so E is equals to, therefore E naught into sine of omega t. Now what about the current here now? Current it will go. So when there is a positive cycle, there is a charging is takes place now. When there is a negative cycle, discharging is going to take place. So therefore discharging means current it is there no, charging takes place, this current is becoming lower no, therefore it is going to get discharge onto that. Therefore this also it will show a certain amount of reactance onto this, right? So what will be the charge here now? Therefore the charge it will be equal to Q is equals to CV. Charge is continuously changing. So therefore Q is equals to C. What will be the voltage across this one? No, is nothing but this one E naught into sine of omega t. This is a charge flown, right? So you can write down the current now. I is equals to dq by dt, right? Therefore you can differentiate it now. Therefore here, so differentiate of this one now, C into E naught, therefore d by dt of sine of omega t. Clear? So differentiation of sine of omega t is nothing but cos of omega t. So I is equals to, therefore cos omega t into omega, therefore so omega into C into E naught into cos of omega t. Clear? Now we can rewrite it as E naught by this, I can rewrite it as like 1 by omega c, because 1 by of this one means it will become like a multiple. So cos is nothing but we can write down sine of omega t plus pi by 2. This is your current, right? So here you can write down this is your I naught. I naught is nothing but E naught by 1 by omega c. So therefore E naught 1 by omega c is nothing but xc. So what is xc now? Xc is nothing but 1 by omega c or 1 by 2 pi f into c. Clear? So what you can call this one now? This is nothing but a capacitive reactance. Why? So because it is depends on capacitive reactance. That means therefore it depends upon the frequency. As frequency changes, so it is also changing onto this. Therefore here you can rewrite it as, so it is capacitive reactance is inversely proportional to the frequency. That means here frequency increases, so therefore Xc will decrease. So when Xc is decreases, therefore resistance is decreasing. Resistance is decreasing means what? It will act like a short circuit now. Therefore it is nothing but a short circuit, right? At higher frequency, so capacitor will act like a short circuit. So therefore at lower frequency, so Xc will be larger. That means what will happen now? When frequency is lower, so Xc will be larger now. Therefore it will be act like a open circuit. So that's why capacitor and inductor so are showing some effect by changing the frequency. That means if you want to alter the frequency, so compulsory either you have to use either capacitor or inductor onto this. That's why capacitor or inductor will act like a filter circuit. We want to filter the frequency onto this. Clear? Understand? No? So therefore here, because it is showing the effect on the frequency onto this. Clear? So this is your capacitive reactance now. Now what will be your phase difference here now? Phase difference, it will be equal to omega t, and this is omega t minus omega t plus pi by 2. So what you will get it now? Phase difference, it will be equal to minus pi by 2. So therefore here phase difference is there now. So phase difference is not nothing but also pi by 2. So again the same thing now. So here if there is a phase difference is pi by 2. So what about this power factor now? Power factor, so what you can write it now? Therefore it will be cos phi, cos 90. So therefore it will be equal to 0. That means so power will not be dissipated across the capacitor. So in alternating currents now there is no power dissipation across the capacitor and inductor. Therefore it is 0. So what about your time difference now? Time difference is also nothing but a t by 4, right? Clear? So can you tell me which is leading and which is lagging here now? So here omega t, so here omega t plus pi by 2. That means so phase of the current is larger now. Therefore what you can write it now? Phase of the current is larger. So therefore current leads the voltage or voltage lags the current. Clear? So in this way you can rewrite it as current leads the voltage or voltage lags the current onto this. So you can write down the phasor diagram now. So what is the phasor diagram here now? So here phasor diagram, therefore here current it will be there now. This is your phasor diagram. So this is your VC. Very important, this most important. Clear? So this is your phasor diagram. So in this way, therefore you can apply alternating current across the capacitor now, right? So these are the applications of our alternating current across the individual devices, no, like resistor, capacitor and inductor. Let us do some simple questions onto this one now. Then we'll apply the this alternating current for 3 of this one now, like RLC circuit now. First let us go for some small questions onto this one now. Clear? Do some simple questions onto this one now. So first of all, let us see here. Let us see, therefore here it will be right here RMS voltage is there now. In our houses, what you are going to get it now, we will get it as like a 220 volts. So this is nothing but a RMS voltage. We want to calculate peak value, peak voltage. How to calculate the peak voltage now? Peak voltage is nothing but a V0 is nothing but a root 2 times of like a VRMS. So root 2 into therefore 220 volts will be your peak value. Suppose here therefore I0 is nothing but a 10 ampere. So what will be your RMS current now? RMS current. What will be our RMS current now? IRMS is nothing but a I0 by root 2. I0 is nothing but a 10 by root 2. So can you tell me which is larger in this one now? In this one now, this RMS voltage and this it will be the peak value, peak voltage. Here peak voltage, peak current, here RMS current. Among this one now, which is greater here now? So which of the values are greater now? You know that peak values are greater. Peak values are greater than RMS values. RMS value is nothing but like a DC. So therefore this is nothing but like a AC. So therefore AC is more danger than DC. Clear? Understand? No? Therefore these are like a simple questions. No, you can calculate it now. Clear? Now let us see how to calculate the RMS values. No, so suppose here now there is a one value it is given. No, I is equals to, therefore this is a current. No, 3 plus 4 root 2 into sine of omega t plus pi by 2 something, pi by 3 something it is given. So this is your some sinusoidal function onto this one. No, you have to calculate RMS value. So therefore IRMS, very important question. No, so in one of your JEE main, no, this question is asked. So in this situation, no, I will give one formula, right, how to do this type of questions. No, so what you have to do, first of all, simple thing, I will not going to explain. No, but so I am not going to do it, so I will explain. No, so what you have to do, you have to square it first. Like RMS means what, right? IRMS means what? So therefore first of all I square, you have to square it. Then you take the average of this one. No? Then you apply the root. Clear? So first of all squaring, so then doing the average. So you can remember this value. Therefore sin theta average value is 0. Cos theta average value is how much? No, it is 0. Sin square theta, therefore average value is 1 by 2. Cos square theta average value is 1 by 2. Therefore these formulas it will be more useful to solve this one. So just number is there, just that is only the value onto this. So in this way you can solve it. No, therefore but I will give one simple formula. So therefore suppose anytime I is equals to A plus B sin theta is there. No, how to calculate RMS? No, IRMS. No, so root of A square plus B square by 2. Suppose anytime one equation is given, A sin theta plus B cos theta, this type of question is asked in the examination. So therefore IRMS value is nothing but A square by 2 plus B square by 2. So substitute here. No, you can use this formula in this situation. No, clear? So very simple one. No, therefore here, so you can rewrite it as root of, therefore this is 3 square plus 4 root 2 whole square by 2, that is nothing but a root of 3 square plus 4 square, so that is nothing but a 5 square, right? So that is nothing but a 5. Clear? How I did this one? No? You already know it, no? That is, right, 9 plus 16 root 25, that is nothing but a 5. This is your RMS value for this type of question on this. Clear? So very important, these type of questions, no, nowadays they are asking in the JEE mains. Clear? So these values also is important for us. Now let us see, we'll apply the, right. So we'll apply, therefore there is a 100 ohms is there, no. So we'll apply this value. Therefore here, suppose here 220 volts and 50 hertz. This is your question is given. Now we want to calculate IRMS, no, and whatever the things, no, you can calculate it, no. Therefore first of all, so you have to calculate IRMS or peak value also they may ask you, peak value, even power dissipated, no. Next one, time lag also they may ask you, right. So first of all IRMS, see one very important point, if these values are given, these are nothing but a RMS values. Clear? 220 it is given like this, that is nothing but a RMS value. So IRMS is nothing but a ERMS divided by R. Clear? Huh? ERMS is how much, no? 220 divided by R value is how much, no? 100. This is your 100. How much now? 2.2 ampere. So I naught is nothing but a root 2 of IRMS. Therefore 2.2 into root 2. So this is your peak value. What is the power now? Power is nothing but a, what is the power factor? You know it, no? So power factor cos phi, therefore it will be equal to, so that is 1. Therefore ERMS into IRMS. ERMS is nothing but how much now? So 2.2 into IRMS is nothing but a, sorry, ERMS is nothing but a 220 into IRMS is nothing but a, so therefore here 2.2. So this 0, 22 into 22, 484 watt. This much amount of power will be dissipated across the resistor. Time lag. So what is the time difference here now? Time difference is 0. Why? Because phase difference it will be equal to 0. Therefore there is no time difference here now. There is no time lag in this. Clear? So in this way you can solve the problems, right. Sometimes they may ask you what will be the equation for this. What is the equation now? Current equation now. I is equals to I naught into sine of omega t. Omega value is nothing but what? So therefore 2 pi ft. Clear? I naught I got it as how much now? So 2.2 into root 2 into sine of 2 pi into f. F is nothing but how much now? 50. 50 into 200, therefore 100 pi t. So this is your current equation after this. Clear? You understand, no? So therefore they may ask you in different ways also, you can try it. Clear? Now we will see here one more question, no? Therefore suppose there is an inductor is there, no? This is one inductor. So therefore 200 volts, suppose 50 hertz, therefore it will be equal to 50 millihenry. 50 millihenry. Suppose these values are given, so you have to calculate the current. IRMS you have to calculate, therefore power, time lag, anything, right. So therefore first of all IRMS, if you want to calculate IRMS, this it is nothing but ERMS divided by XL. First of all you have to calculate XL. What is your XL now? XL is nothing but a omega L. Omega is nothing but a 2 pi f into L. 2 pi f is nothing but a 50. 2 pi is nothing but a, it is also 50. So it will be also 50 into 10 to the power of minus 3 millihenry. How much it will be? This is your 100 into 0. Therefore this 0, this 100, this is gone. This. So therefore it will be remains like a 5 pi. So how much it will be now? ERMS, no? Therefore it will be 200 divided by 5 pi ampere. Clear? This is your IRMS, no? I naught you can rewrite it as, no? What will be the power dissipated? No power. There is no power dissipated. Power dissipated will be 0. Why? Because cos phi. So it will be equal to 0. Phase difference is 90 degree. What it will be a time lag? No. Therefore it is nothing but a T by 4. T is what? Therefore here frequency is 50 hertz. Time period is nothing but 1 by 50. So 1 by 4 into T value is nothing but 1 by 50. 50 is how much now? This 100, 1 by 200. Therefore seconds. This is your time lag. Clear? Now next. So you can rewrite it as same thing. Suppose there is a one capacitor is there now. Therefore C is equals to 100 picofarad. So therefore 200 volts into 60 hertz. Suppose it is given. Now we want to calculate IRMS here, no? IRMS is nothing but a, so this is your ERMS divided by XC. First of all you have to calculate XC. XC is nothing but how much, no? So 1 by omega C or 1 by 2 pi FC. Clear? So 1 by 2 pi F is how much now? 60 into, right, C is how much now? 100 into 10 to the power of minus 12. Clear? How much it will be? Here, therefore, here it will be these 3 zeros, no? Therefore, 3 minus 3 it will gone. Therefore, how much now? 10 to the power of 9 minus 9 taken here, no? 10 to the power of 9 divided by 12 pi. Clear? Clear? Right. So now what you will get it now? 200 divided by 10 to the power of 9 into 12 pi. Clear? So therefore here taken top, no? 10 to the power of 4 minus 9 means 10 to the power of 4 minus 7. Therefore 2 into, therefore 24 pi into 10 to the power of minus 7 ampere. Clear? So what will be your power dissipated? No, power dissipated it will be equal to 0 onto this one. No? Also time lag also you will get it now, time lag. So what you will get it now? T by 4, 1 by 4 into 1 by 60. Therefore 12, 12, 24, 240 seconds. Clear? So in this way you can calculate so about the application of our alternating current across this capacitor, inductor and resistor. Clear? Question. So here it is given this graph now between impedance and this omega. Therefore this is for impedance circuit. Therefore there is an impedance is there. So therefore here an alternating current it will be there, no? So here the frequency changes, therefore impedance it is going to change. So how it will be there? Impedance, no, impedance is nothing but a, or resistance also you can take it onto this. So resistance is not required onto this. So here impedance is nothing but a XL. So it is nothing but a omega L, therefore 2 pi F into L. So therefore omega, right, this is 2 pi F is L is not required here, no? So here impedance is nothing but a omega L, therefore Y is equals to Mx. It will be like a straight line onto this, right? So straight line, so therefore slope it will be gives like a slope, it is going to get it like a L onto this. Therefore here omega L is nothing but a, here you can write L into omega, therefore Mx. Therefore slope you will get it as like a L. Now what you can write it now? We want to find it as like a L1 by L2, that is nothing but a tan slope. Therefore tan 45 by tan 30. Tan 45 is nothing but a 1. So right, so it is nothing but a 1 by root 3. So tan 30 is nothing but a 1 by 2 by root 3 by 2, 1 by root 3, that is nothing but a 1 by root 3. Therefore it will be a root 3 formula. Clear? Now let us see one more question now. Okay, so this is your instantaneous value, it is given now, right? So we want to calculate what will be its value at t is equals to t by 8. Just simple thing, no? Therefore I is equals to I naught into sine of 2 pi by t into, therefore this is t, clear? So I naught into sine of 2 pi by t into t by 8. So t cancel, no? Therefore pi by 4, I naught into sine of pi by 4. Pi by 4 means sine pi by 4, sine 45 means I naught by root 2. So will be your instantaneous value, right, at the time t is equals to 1 by 8, t by 8. So same type of question, no? So find I at here phase is extra is given, no? I is equals to again I naught into sine of 2 pi by t into t value is nothing but a t by 2 minus pi by 6. So t cancel now, 2 also cancel now. Therefore I naught into sine of pi minus pi by 6. So therefore sine 180 minus theta, therefore sine 180 minus theta is nothing but a sine theta. Therefore I naught into sine of pi by 6. Pi by 6 is nothing but a 30. So I naught into 1 by 2. Therefore I naught by 2 will be your instantaneous value now. Clear? Now here we want to calculate in this one now. Therefore we want to calculate IRMS. We want to calculate. What is that IRMS value now? How to calculate it now? Therefore here root. So this is value is 1. Therefore 1 square plus this value is minus 2 whole square by 2. How much now? Therefore 1 plus 4 divided by 2. So root 5 by 2 will be your this one. Root 5 by 2 is nothing but nearly root 2.5. 2.5 means 1.4, 1.6 or 1.7. Therefore we can draw it now. Here it will be your IRMS. Nearly 6 ampere. Clear? Yeah, therefore this type of question, no, it is it looks like so many difficult question like this, no, but right, it's a very simple one, no. Let us see. So he is asking that what will be the impedance at high frequency. Frequency is very high here now. Frequency is high. So you should remember that frequency high means at higher frequency, so XL will be large. XL will be large and XC will be small. So when XL is larger, therefore this will act like a open circuit, no, and XC is small, therefore we can call it as like a short circuit. Clear? Short circuit means what will happen now? Open circuit means this inductor, no, there is not there here, no, this is like a open circuit now. So how the current it will flow here now? The current it will flow from this one now, it will comes to here, because it is an open circuit, it will go here, no, go here. This is short circuit, no, short circuit only. So capacitor is also short circuit only, it will go here, it will not come here, no, it will go here, it will go to here, right? So therefore how what are there now? Therefore R1 and R3 only is there, no. So therefore impedance it will become like a R1 plus R3 will be your total impedance. Very simple one, no. Clear? So don't think like it is a complicated one, no. Therefore basics should be very strong onto this. Clear? Very easy question, no, right? Now suppose there is a inductor is there, this one bulb is there, so it is glowing now. Okay, so you can do two questions in this one, no? Suppose if the frequency is increasing, what will happen now? So frequency is increasing, so therefore across this one now, this inductor is having this one now, XL will increase. When XL is increasing, so potential difference across this one now, so I into XL. Therefore potential difference across this one now, so VL also increases. Whatever the energy is there, it is gone to this one now. So once this energy is gone to this, therefore it is VL gone to this, therefore potential across this one is going to get decreased. So therefore potential across the bulb decreases. When the potential across the bulb decreases, therefore brightness of the bulb decreases. Brightness of bulb decreases. Clear? So reverse scenario, if it is frequency is decreasing also. One more scenario is there now. Let us see what is that now. Suppose same question now. There is an inductor is there. This is an inductor. So there is a one bulb is there now. So here it is connected here now. So there is no change in the frequency here now. But what will happen now? Therefore here what we are going to do? We are going to insert here one ferromagnetic material. Ferromagnetic material. When ferromagnetic material, what will happen now? When it is inserted, the magnetic field across this one is increases. So magnetic field increases. Why? So magnetic field increases. So field lines are increasing, therefore more amount of opposition will take place now. Field lines are increasing, therefore XL will increase. XL will increase because more number of field lines are there now, more opposition will be there, like a Faraday's law. So therefore what will happen now? XL will increase. When XL is increasing now, so therefore VL across this one is also increases now. When VL is increases, therefore what will happen now? Bulb, brightness of the bulb will be decreases. Therefore brightness of bulb decreases. Why? Because potential across this one now, VL is increasing means potential across this bulb decreases now. Clear? That's why therefore the bulb will be glows dimmer. So when there is a inserting the ferromagnetic material now. Clear? Now let us see here also the same thing now, same situation now. Suppose here the bulb is glowing now. Now again suppose frequency is increasing. So what will happen now? Frequency is increasing. Therefore what will happen now? Xc is nothing but 1 by 2 pi Fc. So frequency is increasing, therefore Xc will decrease. When Xc is decreasing, therefore Vc across this one is decreases. When across this Vc is decreasing now, so V across the bulb will increase. So that means V across the bulb will increase. Therefore bulb glows more brighter. Clear? So again same type of question now, one more question you can add it here now. Suppose there is a one capacitor is there, this is one bulb is there no, right? So now frequency is constant here now. Suppose in this one now some dielectric slab is inserted onto this. Some dielectric slab is inserted. Therefore when dielectric slab is inserted, what will happen now? So capacitance will increase. Capacitance will increase. When capacitance is increases, Xc what will happen now? 1 by 2 pi Fc. So capacitance increases. So Xc what will happen now? Decreases. When Xc is decreasing now, Xc is decreasing. So therefore Vc also decreases. So when Vc is decreasing, therefore potential at the bulb it will be increases. Therefore when you are inserting the dielectric slab now, bulb glows, right? So bulb glows more brighter. Clear? So in this way you can solve the questions no. So in this way you can solve. Even like our airport security is there now, airport security, therefore any shopping complex now you go now, there will be one metallic frame, it will be there. If you go through that, therefore any like metal objects if you are carrying now, therefore automatically some beep sound it will become now, therefore security alarms like that now. So therefore that it will work based on what now? It's work based on the principle of resonance will take place now. So suppose if you are carrying the metal onto this one now, therefore the inductance of that it is going to change. Once inductance is changed onto this one now, therefore resonating frequency it will change. Why? So Y therefore 2 pi into square root of LC. As L is changed onto this one now, automatically therefore frequency will be changing now, therefore the resonance will not be takes place. So therefore here it will be able to create a like a some buzzer sound onto this, right? So even airport security also will use like a resonating condition of our alternating RLC circuit now, right? So these are the concepts now, right? Right students, till now we discussed this one now. So it's already right, it's a long video, no? So now we'll do like a second part of this one, no? Like we'll apply alternating current across RLC circuit and RL and RC and LC combinations, no? And how to solve the type of problems, no? We'll do as like a next part of this video, right? So thank you for watching. Please subscribe to my channel, no? And learn the physics very easily, right? Thank you.